Hey guys, I hope your quiz went well. Section 6 for day 1 is just a lot of properties, okay? We're not doing a ton of problems. We just have to talk about a bunch of different properties for special parallelograms. So first one we're going to start with is rectangle. That should be something that's familiar to you. So a quadrilateral with 4 right angles is a rectangle. And you guys all know that already. You've dealt with rectangles for a really long time, I'm sure. So we're going to talk a little bit more specifically about what that means, though. So if a quadrilateral is a rectangle, then it is a parallelogram. Every single rectangle is always, always, always going to be a parallelogram. Now, sometimes parallelograms are also rectangles. Sometimes parallelograms can be a rhombus or a square. Just kind of depends on what other properties you see, okay? But anytime you have a rectangle, it is also a anytime you have a rectangle, it is also a parallelogram, okay? So, our hypothesis, our if part, we've got a quadrilateral that's got 4 right angles. So that means we know that it is a rectangle. That means that ABCD is a parallelogram. Okay. Now, if a parallelogram is a rectangle, then its diagonals are congruent. Okay, so we said, hey, if it's a rectangle, we know it's a parallelogram, so that's cool. That means that this figure also has all those properties of a parallelogram that we talked about. Opposite sides congruent, opposite sides parallel, consecutive angles supplementary, all that good stuff. Well, now we're taking it one step further, and we're saying, hey, if we've got this rectangle, then the diagonals are congruent to each other. Okay, so what that means is that in this picture, we've got a quadrilateral with 4 right angles. So we started with if rectangle, then diagonals are congruent. That means then that AC is congruent to BD, because those are my 2 diagonals. Okay. All right, a rhombus. This one you may or may not have heard of before. I'm not quite sure. A rhombus is a quadrilateral with 4 congruent sides. Okay, so if we look at that very first picture, to go with that first theorem, we've got this 4-sided figure, so a quadrilateral, and all of the sides are marked congruent. They've each got 1 tick mark on them. So that means that that quadrilateral is a rhombus. Okay, and a rhombus is always a parallelogram. So if you look at a 4-sided figure and all 4 sides are marked congruent, it's called a rhombus. All right, but that rhombus is also a parallelogram. Okay, because if we think about it, opposite sides have to be congruent in a parallelogram, right? Both pairs of opposite sides. Well, AD is congruent to BC, that's one set of opposite sides. And AB is congruent to DC, that's one pair of opposite sides. Both pairs of opposite sides are congruent, it's a parallelogram. It just so happens that all 4 of them are congruent to each other, but that's okay. That's still a parallelogram. So ABCD is a parallelogram. Okay. Now we're going to look at some properties of rhombus then. So if a parallelogram is a rhombus, then its diagonals are perpendicular. Okay, so this is not true for every parallelogram, only when it's a rhombus. Okay, so what that would mean then is that all of these segments are perpendicular, so we can just make a nice box there. So it's going to mean that BD, one of the diagonals, is perpendicular to AC, the other diagonal. Okay, and again, keep in mind this is only when it's actually a rhombus, just like the diagonals are only congruent if it's a rectangle. Okay? Then we have another really cool one. So if a parallelogram is a rhombus, then the diagonals bisect a pair of opposite angles. So we have these diagonals going across, right? They're bisecting the angles that they hit. So for example, we've got angle ABC over here. Angle 1 is congruent to angle 2. It's being bisected, that angle ABC. Same thing with this angle. Angle 7 is congruent to angle 8. Over here, angle 3 is congruent to angle 4. And down here, angle 5 is congruent to angle 6. So if we've got this rhombus, then the diagonals are bisecting the angles. Okay, but again, it's only when it's a rhombus. This is where things are going to start to get a little muddy. Okay. One more special parallelogram that we've got to talk about, and that is a square, which I know you guys know what a square is, but a square is a quadrilateral with 4 right angles and 4 congruent sides. Okay, I know you guys have dealt with squares before, so we are not going to spend a ton of time talking about that in particular. But we are going to talk about is this picture down here. All right, you guys have probably seen a Venn diagram before. This one's a different take on a Venn diagram. It's got one inside of another, right? This outside box, we're going to call that quadrilaterals. Okay, and we've been talking about quadrilaterals since we started talking about polygons. A quadrilateral means that it's a shape with 4 sides. It's a polygon with 4 sides. Okay, so anytime you have a 4-sided polygon, it is a quadrilateral without a doubt. Okay, now we're starting to talk about ones that are a little bit more specific. So we started first with talking about parallelograms. Okay, and we said, hey, if you've got opposite sides parallel or opposite sides congruent or opposite angles congruent, that kind of stuff, then we know that it's a parallelogram, right? So this is a specific type of quadrilateral. Okay, well, moving even more inside, we said that if we've got a parallelogram that's got 4 right angles, that's a rectangle. Okay, so a rectangle is always a parallelogram. A parallelogram is sometimes a rectangle. Okay, so this nice picture is going to kind of help us see that, ooh, sometimes a parallelogram is a rectangle because I have to move inside, right? But a rectangle is always going to be a parallelogram, and a parallelogram is always going to be a quadrilateral because I'm working my way out of these circles. Okay, so this is going to help us keep track of all of these properties that we're going to list. All right, then we said a rhombus. Okay, well, a rhombus is always a parallelogram and always a quadrilateral, but going the opposite way, it's only sometimes. Sometimes we have a quadrilateral that's a rhombus. Well, a rhombus has to have all 4 sides congruent. Okay, so that's how we identify a rhombus. But once we do that, then we know, oh, it's also parallelogram and quadrilateral. Okay, and then the very last type of quadrilateral that we talked about is a square. And you guys know what that is. That is the most specific type of parallelogram because a square is also a rectangle, and it's also a rhombus, and it's also a parallelogram, and it's also a quadrilateral. So squares got it all, okay? A square has all the properties of a rectangle, a rhombus, a parallelogram, all right, and quadrilateral because it's a 4-sided figure. So we're going to talk a lot about that and a lot about all these different properties, but I think that this visual kind of helps us see that they're all related to each other. We just need to figure out how. Okay, so when we are in class tomorrow, we will work on what all these different properties are, and then we'll start working with the different properties in terms of solving problems. All right, I will see you guys later. Bye.